All right, this is Algebra 1, Lesson 1.2 and 1.3. This is Part 1, and today you're going to learn about exponents and square roots. So you should have your graph paper composition notebook out and ready to go to take notes. If you don't have a composition notebook, just use a regular piece of graph paper and we will transfer that in as soon as you have a notebook. And we're going to talk about notes in detail a little bit later. So for today, I just want you to open up your notebook and you can skip the first 2 or 3 pages and go to the 3rd or 4th page, and you're going to start taking notes on this page. And here's how you'll set your paper up. At the top, you're going to write lesson 1.2 and 1.3, exponents and square roots. So for the future, you'll always title your notes with the lesson and the topic. The second thing you're going to do is write an essential question. So right below the title, you're going to write EQ, which stands for essential question. And today's essential question is, how do you simplify exponents and square roots? Now, I know I'm moving quickly and I'm talking fast, but the beauty of watching a video and taking notes is that at any point, if you start to fall behind, simply pause the video, get caught up, and then resume. Or if you need to go back and watch again because you missed something, back the video up, watch it again, and take notes. So the first thing we want to do is define what an exponential number is. So in your notes, you're going to write exponential number or just exponent. And then you can write a 2 raised to the 4th power. You can write it super big, but you really don't have to. You just have to make sure you notice the difference between the big 2 and the little 4. The 2 is what's referred to as the base, and the 4 is called the power. And you say it 2 raised to the 4th. You don't say 2 with a little 4 thingy or 2 times 4. It's 2 raised to the 4th power. When you have an exponential number like 2 to the 4th, to simplify means to write it in its simplest form, or in other words, complete the operations. So copy down the definition for simplify. Again, it's to write in simplest form or to complete all the operations. Now, if you need to pause the video at this point, do so, but copy down example 1. So you're going to write example 1. If ever you want to abbreviate, that's great. You can write example 1 like that. You can write E1, you can write P or problem 1, however you choose to do it. You just need to do it in a way that works for you, that shows that we're doing the first example. Copy down this table with exponential, expanded, and simplified, and notice that the expanded portion is a lot wider. That's on purpose. So if you need to pause the video to do that, pause the video and copy this down. All right, there are numbers that are written in exponential form, like the one I just showed you, 2 to the 4th power. This number can be written in expanded form by writing out what 2 to the 4th power means. It means 2 times 2 times 2 times 2 4 times. 2 to the 4th power means 2 times itself 4 times. To simplify that, you just multiply. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. That's the simplified version. So if I were to give you a different number in expanded form, like 3 times 3 times 3, you should be able to multiply 3 times 3 times 3 and get the simplified version, which is 27. But you should also be able to tell me what the exponential version of 3 times 3 times 3 is, and that's 3 raised to the 3rd power. That also works for fractions. 2/3 times 2/3 times 2/3 times 2/3. The exponential version is, how many 2/3 do you see being multiplied together? 4, so it's 2/3 to the 4th power. Now notice I'm putting parentheses around it, so I make sure I know that the fourth power is applied to the whole fraction. You can find the simplified version just by multiplying 2 times 2 times 2 times 2, which is 16, and 3 times 3 times 3 times 3, which is 81. So in your assignment today, you're going to see a table like this, and you're going to be asked to write out numbers in expanded, exponential, and simplified forms. Okay, when you raise a number to the second power, what you're doing is you're multiplying that number by itself twice. A short way to say 1 to the second power is to say that it's squared. So what I'm going to have you do now is copy down all these numbers, 1, 2, 3, all the way through 16, raised to the second power. These are known as the perfect squares. And it's important in this class that you know by memory the first 16 perfect squares. So pause the video, copy down what you see, 1 squared, 2 squared, all the way through 16 squared, and then fill in as many as you possibly can. When you're done filling in all the numbers you can, if you get stuck, hit resume and I'll show you the answers. Okay, the answers to the first 16 perfect squares are 1 squared is 1, 2 squared is 4, and so on. Now, if you just sat there and then pretended to think and then copied the answers down, that's fine, but you're going to need to memorize these first 16 perfect squares so that you can use them in future math problems. All right, you don't have to write this down, you should just watch. The square root of a number, first of all, this symbol is the square root symbol, also known as a radical. The square root of a number is equal to what number squared gives you the number inside. For example, if I put the number 25 and I ask you what's the square root of 25, you would ask yourself what number times itself or what number squared is 25. And in this case, the answer is 5. 5 times 5 is 25. So the square root of 25 is 5. Now, I'm hoping this is easy review. I just want to make sure we're all on the same page. So if I go backwards, all of these red numbers are perfect squares. If I take the square root of a perfect square, I always get a whole number. The square root of 81 is equal to this number, 9. The square root of 100 is equal to this number, 10. The square root of 225 is equal to 15. Squaring a number and taking the square root, those are like opposite or inverse operations. So, again, pause if necessary, copy down example 2, and tell me what's the square root of 16, 81, and 196. So for the square root of 16, you ask yourself what number squared is equal to 16, and that is 4. The square root of 81, the number squared that equals 81 is 9. And for part C, the square root of 196 is 14. Now, if you had the first 16 perfect squares memorized, this answer should have come to you quickly. All right, the last example I'm going to show you is what happens when you have the square root of a number that isn't a perfect square, like 27. So there's a method that I'd like you to learn and use, and it goes like this. You first take the number 27, and above it, you write an empty square root, and below it, you write an empty square root. And then you find two perfect squares, one that's just above the number or greater than, and one that's just below or less than. So two perfect squares that surround the number 27 would be 25. 25 is a perfect square and it's just less than 27. And 36. 36 is a perfect square and it's just greater than 27. The square root of 36 is 6. The square root of 25 is 5. The answer to the square root of 27 has to be somewhere between 5 and 6. So to get a really accurate answer, you ask yourself, is 27 closer to 25, or is 27 closer to 36? And the answer is that 27 is closer to 25, so the answer should be closer to 5. So make a guess, 5.1 or 5.2, since that's really close to the number 5, and that's it. You've estimated the square root of 27 by using perfect squares. All right, that's the end of the notes. Now your job is to go on to Schoology and find the quiz that I've set up for you and complete the 7 problems. You're going to find those problems on Schoology, and you'll find them in the Chapter 1 folder. Open that folder up and you will find the assignment for today. After you finish with that, I will give you further directions in class.